So today we're doing an experiment to help determine whether we think radio waves are longitudinal or whether they are transverse. So according to my new radical theory that says that radio waves are actually longitudinal, it means that we have this radio antenna here. It's straight, and it's going to be sending out radio waves in a longitudinal fashion, which means they're going to be sending in waves like ocean waves. So they're going to be heading out this way, and they're going to be hitting this receiving wire this way and generating a signal because it's pressing into this wire and causing electricity to flow. And that's opposed to the conventional theory that the radio waves are electromagnetic in nature and that there's actually an electric wave that's going back and forth between these two dipole elements here. So what we have here is we have a transmitter, frequency transmitter, and this side is the ground and this side is the signal. So theoretically we have these dipoles in opposite phases here, so the electricity will go this way and then go back that way, creating a sloshing effect, and it's then is received by this dipole antenna, which then also receives the sloshing effect, leading to a voltage. And we have an oscilloscope here, and we can see the signals kind of bouncing around in there, but I'm going to stop it, and we're going to try and see about how big that signal is. And it looks like it's like maybe 3.5 units there. A little bit hard to measure there, but yeah, about 3.5 units. So the idea is now, instead of having it slosh between the elements, I'm going to connect both of these to the signal side, so that both will be driven theoretically evenly at the same rate. And I would predict that there's going to be somewhat less signal in there because there's going to be less differential between the two sides here than there was before, since there's not going to be any actual sloshing. So let's see if I can do that. I have to put the camera down for a second here. I'll try and adjust that. Okay, so both antenna leads are into the same terminal there. And now we're going to go back here and we're going to go and measure what does our signal look like now. Okay, so what do we got now? So we've got something like 3 units. So it is less. I mean, it's not 0. I mean, I might have predicted that it might have been 0, but this is such a noisy environment that we're not seeing that there's nothing going between these two because they're perfectly balanced. But we are seeing that there is a reduced signal here at the receiver, which I don't think can be explained by the standard transverse theory, since the transverse theory would probably say it doesn't make any difference whether it's singly driven or alternately driven. But in the longitudinal case, where this side of the wire is now being driven exactly the same time as that side of the wire, would lead to a reduced voltage potential in the middle there. And that's what we seem to be seeing.